Всем привет! Меня зовут Артур, и вы, возможно, знаете меня по различным докладам об архитектуре, чистой архитектуре, о том, как все сделать хорошо и не делать ничего плохого. И сегодня я буду экспертом на докладе, посвященному архитектуре. Этот доклад будет рассказывать Giorgio, и, как вы, наверное, обратили внимание по введению, Giorgio не говорит по-русски. Поэтому приготовьтесь, вся наша дальнейшая речь будет на английском, и совсем скоро мы начнем. Джорджио имеет богатый опыт по всему, что касается архитектуры и разработки, и сейчас мы об этом поговорим. Hey, Giorgio. So, yeah, I've just introduced myself, and here you are, Giorgio Natili. Can you please tell a few words about yourself, a few words about your experience?
Absolutely, Arthur. Thanks, first of all, for having me and for the all the support that you're giving me for this talk. I'm Giorgio Natili. I'm an engineering lead, 21 years that I do this job. Still passionate about looking at architecture, discussing opportunities, trade-off, understanding what are the simplifications that we can have around any system. I truly believe that we all know how to design the best system, how to do the best design ever, but it's way harder to identify the simplification that can make different our design and can make it more easy to bring to the market and to the hands of our customers to get some sort of benefit. Passionate about
Mhm.
TDD. I've done several talks, also one here at Mobius 2 years ago.
Cool.
Excited about be here and ready to have a chat with you.
Great, thank you. And like a preparation for talk, let's do it like in the baby steps. And my question for you would be, uh, of course, like each of us at some moment start as a developer intern, maybe as a junior developer. And can you remember basically how did the journey started for you?
Yes, I think that is an interesting story. It was more than 21 years ago. I was doing some training and some courses on office automation, and I was using Excel. I was very excited about Formula in Excel, and a friend of mine at that time told me, well, if you like Excel, you would love Flash. Flash is an old technology back in early 2000. And I went and I started to take a training and its training center. And 2 days after, at the end of the training, I went to a bookshop. I bought 2, 3 books of about Flash, and a few months after, I was teaching Flash. So that's how I
Oh,
started with um, the excitement of see how an Excel formula can make an Excel spreadsheet really intelligent, and then seeing that scripts inside Flash can bring interesting user experience to the end, into the end of the customers.
yeah, and that's an interesting thing that basically if you want to excel at something, you need to start teaching it. And yeah, basically this is the way I started my programming journey as well to some extent. That after like learning some basics, I started to teach school kids, and that helped me to better understand how to program like overall. Cool. And do you remember at which moment have you started to think about, okay, what are the best practices? How should I structure my code? What is the architecture? I
Yes, I do.
Mhm.
That's a nice question. Thanks for asking. I remember I was working on a rich at that time were called the rich internet applications. Was a rich internet application that was an online game for a TV show in Italy, and I structured the project decently. But when we were in the last mile where bugs start to pop up, I started to find myself really patching code here and there without too much of confidence in what I was doing. Everything went well, but that was for me a big haha moment when I started to understand how much more important was organizing my packages, my interfaces, and exposing at least the minimum functionalities to in such a way that can be tested and automated. And that was my moment. It was 2003, if I remember correctly, or
Oh.
2004. Yes.
Yeah, sounds really interesting. Cool. And I think that at this note, we can start the presentation and let's proceed.
Cool. Thank you. So, welcome everybody. Today we'll talk how to navigate the MV mess. in Android, with a specific focus on Android. The reason why of this talk, it's pretty simple. There are many patterns. There are not enough guidance to have these to make a decision, to make a conscious decision about what pattern is the best. A little bit about myself. I am Giorgio Natili. I am a director of software engineering at Capital One. A couple of years that I work for this company. I manage the integration of the business intelligence into the Android, iOS, and web experience for our customers. Before that, I worked at Amazon, a couple of years in payments and a couple of years in Kindle, where I managed the Kindle rendering team. That was an interesting experience because it was a C++ layer shared across Android, iOS, web, Mac, and Windows. That was another interesting time of my career where I learned the importance of consistency for the software. Before that, I worked in a security company, Akamai Technologies, and at Tech, and a decade ago, I was owning my own company. All the same drive, the thing that drove me to across all this experience has always been my passion for clean architecture, good code, having fun when you write code, and delivering value to the customers. Today we'll talk about system design and quality attributes. We'll discuss and understand what are trade-offs and how you can structure your conversations around trade-off, how to perform intermediate design reviews, and why the intermediate design review can be a powerful tool to prevent you to waste any money and any resources and any time that you usually don't have when you work in this industry. We'll review some of the architectural Android architectural patterns, and we'll do considerations on that we should keep in mind when picking an architectural patterns. Last part, I will tell you some anecdotes on my experience in the enterprise, where you can have federated teams, centralized teams, and how the architectures impact all of this. Disclaimer, the opinions expressed in this presentation are my own opinion. I'm not representing any of the company for which I worked or I work. And I put the best effort to make this content accurate, but errors may occur. So please bear with me. If you see anything wrong, just let me know. I will fix it. The content has been curated to the best, to my best ability to make it very inclusive, gender neutral, and the slides deck are minimal. The reason why is because I want them to be readable, presentable, and accessible. If you want an annotated version of the slides deck, just tweet me, send me a message, and I will be more than happy to send it out. Cool. Let's get started. So every system should be driven by quality attributes. When you talk about quality attributes, you are not talking nothing more than business requirements that your stakeholders are expressing. They're expressing this in any forum. It can be an email, can be a spec document. But in any case, these are the drivers that should bring you to deliver a system that matches specific criteria. For instance, you can be asked to build a system with high availability, resilience, and security, but at the same time, extremely accessible and usable. It's almost impossible to identify all the quality attributes that a system can have because they evolve with the system itself and with the system definition. But it's important keeping them in mind. A starting point is that you have at least 6 quality attributes that can be applied to any system, to any app. Performance, reliability, availability, security, modifiability, and subsetability. So at this point, I'm curious to understand also, or actually, I want to invite you to make a reflection on what are the quality attributes that matters for you. For instance, for me, there is deployability that is important. I want to understand how much my system is deployable and also how much my system is easy to debug.
Sure. Do you hear me?
Yes.
Cool. Yeah, I think that's a common problem. And especially if you come to your product manager and ask like, oh, okay, what quality attributes do we want to have? What they will answer? We want to have everything. It should be quick, it should be modifiable, it should be secure. I mean, everything at once. And that is probably the biggest problem with quality attributes that I see. And if we're talking about our app is an app for barbers, and basically they are using it for work. They are doing like different scales and stuff like that. And that's why it is important that it is available regardless of if there is some network, if there isn't network, and I would probably put it into availability. That's one. And second, because barbers, they're kind of stylish and they look they like everything that looks nice and smooth and stuff like that. And we can argue if it's like a performance or if it's something like, I don't know, good lookingness quality attributes, because you can basically take almost every word and create a quality attribute out of it. But something like this smooth working in terms of the FPS and stuff like that, this is probably another one important for us. And the last is usability, because if a barber can't create a booking, if they can't like change a booking, they will definitely be upset.
Absolutely, and all these are good points. And you made a very, very great point, Arthur. Everything it's a little bit different accordingly to the company and to the app. So performance for you can be the FPS. For others, can be the time to respond to a broadcast message, whatever, right?
Mm-hmm.
The quality attributes are generic enough and must be general when we have these kind of discussions, because then they became very specific to the system that we're talking about, and sometimes also to the component or layers of a system.
Sure.
Well, for instance, let's go into performance, given that we were discussing some ambiguity around that. So performance is the ability of a system to allocate computational resources to satisfy timing requirements. What does it mean in practice? It means that, for instance, it's the measurement of the time that you need, that your system need to respond to an external stimulus, like a status change in the connectivity or battery change, or can be the number of events that the system can process in a given interval of time. And this is true for backend and for client-facing application. Reliability, it's the ability of a system to keep operating over time. And in many cases, it's also the mean time to failure, how much time that you need to have the system failing. Because I think that everybody knows, but every system will fail eventually at some point in time. The only thing that you don't know is when, but your system will fail for sure. Availability, it's how much time your system is up, the portion of time that your system is up and running, and how recover from any fault, from any issue. On backend, there are many strategies that you can have that you can implement to detect the fault of a system. Can be monitoring, can be heartbeat, timestamp, sanity checking. But on the client side, there are other techniques. You can, for instance, prevent ANR having services, having a better thread management, and you can make your application way more available than expected. In a mobile app, for instance, how we can make our app more available. I have some ideas. Arthur, do you have any?
And I mean, probably it depends on, what do we mean about the availability? And as I told you before, what if the user doesn't have network connection? Probably we still want the app to work, at least to have like some of the features, and ideally to be able to do like everything offline, and just when internet is getting back, then we can send everything to the server. That is
absolutely
one of the things.
For me, the three major vectors are offline support, data synchronization, and client-side caching. These make my app way more available because I can manage situations where we don't have connectivity. For instance,
I would
go ahead.
And I would add even one more thing, as we have discussed, this availability is kind of a vague term, and can we consider an app to be more available if, for example, a user doesn't have to sign in or sign up in order to start using the app, because the app kind of becomes more available to them. And this is an
That's
interesting twist.
Yep, that's definitely a case. One app which I worked on had a non-authenticated screen that was leveraging local storage to show some data, obviously not sensitive data, but was a good experience because then the user can immediately interact with the app, and then if more is needed, then authenticate and full access to the profile and the personalization of every single screen.
Sure. And yeah, continue.
So, for instance, we spoke about cache, right? It's extremely simple, this diagram, but give you an idea of how you can make your app way more available. Instead of eating directly your API, you can eat a caching layer. The caching layer can return you data, and you can have an invalidation mechanism that will allow you to show always fresh data, but at the same time, it's better showing stale data rather than showing nothing to a user. So you can have a repository, a cache, and an API in an API layer in your app in any system, and implement a way more available app. Security is how you and your system resist to unauthorized attempts or denial services. For instance, on services, you can design your code in such a way that you prevent SQL injection. You can encrypt password. You can restrict access with authentication token. On a mobile app, especially on Android, you can have implicit intent that launch at least two possible apps on a user device and let the user make a choice. You can use a signature-based permission. You can disallow access to the mobile app content providers, and you can sanitize logs. One thing that a lot of time happens in every app is that logs contain sensitive information and compromise the security. I once implemented a logging system, designed a logging system that was leveraging also machine learning to prevent the propagation of any sensitive data. And this is one of the common pitfalls that you may see in any mobile app. Modifiability. It's another important quality attribute. It determines how easy or not it's make a change to a system. There are it depends on the size of the project, right? Also on the quality of the structure and architecture of a project. But there might be a situation where to make a simple change, like adding a button or changing the content of an app, can take days. Instead, it should take minutes. So you can use several strategies to implement modifiability. You can leverage indirection and use a mediator to allow consumer and data producer to communicate without directly knowing each other. You can keep them separated and separate components and layer in modules of the application that are orthogonal aspects of the architecture of your system, and many others. Subsetability. For me, this is one of the most important. Sometimes it's the one that is very not too much discussed, but the ability to support the deployment to production of a portion of your system, it's essential. Imagine that this is very true for backend and front-end application. Doesn't matter, because on backend you can have multiple microservices, right? So you can deploy what you need and when you need, and potentially without creating any side effect. When you discuss and talk about Android applications, you can use Android app bundles and serve an optimized APKs and then download the rest of the code on demand. These help you to eventually deploy only part of a system on the client side. You can use this technique also to identify even better what are the modules and create more granular modules inside of your application. You will have better side benefit like better build speed. You will have an easier way to debug your system, but even more, you can discuss about a subset of your system without forcing everybody to understand the whole picture. Quality attributes, all of them, influence your architectural decisions and the patterns that you pick. What is important to acknowledge is that these attributes are not clear. It's by definition, right? They come from stakeholders. They can come in the form of, I want the system to be secure. I want the app to be reliable. But this doesn't mean anything, right? Until there are no measurement, until there is not a way to clarify and understand precisely what a quality attributes means. To leverage this, we can talk about the architectural trade-off analysis method. But before I move to the next session, Arthur, do you or the crowd have any question for me?
Yeah, it looks like we don't have any questions from our audience yet, but actually I wanted to discuss with you a bit one more quality attribute that is like very, very popular for backend, scalability.
Oh,
And
sure,
what do you
yes.
think is analog of scalability in Android development?
That's a great question. Well, for instance, for me, one analog of backend scalability into an Android app is the ability to consume and parse more data. Let's imagine that you have just an app that it's starting the journey on the store, and it's browsing whatever content. Okay, the content is user based. As soon as the app gain popularity, your users will become millions, and the content will become maybe trillions, right? And the data will increase. So the ability to scale and consume large amount of data set without compromising other quality attributes like performance, it's an equivalent of scalability in an Android app.
Yeah, interesting. Because I was looking at this question like from the other angle of view. For example, when we are talking about scalability in backend, we mean that okay, there was 100 users, now there are 10,000, and the app should like work for all the 10,000. And I used to work for a project for Indian market that had like tens of millions of users with many different like phones. And for me, the scalability was the fact that the app could work on all these different like manufacturers, on the like cheap phones, on expensive phones, and basically to work well enough in all of them. So yeah, and that's basically probably
that's an
and I
interesting
think that
perspective, right?
and I think that this is basically a good kind of connection to your next part. As I remember, you will talk about the ATM technique, right?
Yes.
And yeah, basically, and one of the steps is how do we define quality attributes? And please continue. Thank you.
Absolutely. And again, everybody can see how same words sometimes means different things, right? Both Arthur points and my points were to the point of scalability, right? And they had a different perspective and different point of view. Let's talk a little bit about architectural trade-off analysis. The architectural trade-off analysis, or in short ATAM, is a risk mitigation process that we use in software development. Why we want to mitigate risk? Because we want to deploy systems that are stable, that generate business or fun or whatever you are looking to generate and create with your system and with your app, but you don't want to take too many risks. Risks are cost, and nobody like to pay heavy bills. The architectural trade-off analysis method assesses the consequences of any architectural decision that you make. Another interesting thing is that what is assessed to the ATAM is that also the decisions that you don't make will be assessed, because when you run use cases through your quality attributes, you will see that some of the decisions that you haven't made or you postponed will bite you back. The reason why you want to assess the architecture, it's because you want to have conversations with all your stakeholders. You want to have your architects in the team, your engineering team, and the evaluator team. ATM brings together all these stakeholders, and the goal is to have a structured conversation. It happens in every company, in every team, that there are a lot of conversations. Not often enough there are structured conversation. The difference between a structured and a conversation is that if we talk without a structure, we may land wherever. If we have a structure that is driving us, we have specific goals, and we can get to an outcome that is what it's needed to move our project to the next step. For instance, the architects should present the architecture in a format that is agreed between the various stakeholders and that expose their thought process without deviating too much from the conversation that we have. Managers can take decisions, stakeholders can clarify the quality attributes, and the team of evaluators probe the architectural constraints against the quality attributes. The ATM life cycle, it's pretty simple. It's presentation, analysis, testing, and reporting. During presentation, you have not only architects that present their architecture, but stakeholders and product owners that present the business drivers. Business drivers can be in any format, can be slide, PRFAQ, 1-2 pagers. There are many techniques. Stakeholders present the drivers and the goals that they want to achieve, and they have to provide you with some KPIs. This means that you have something that is measurable to determine the success of the system that you're building. Architects that are not the evaluation teams, or architect if you're working with a single architect, should present the technical constraints in that the system is facing and the other systems with which your app should interact and the architectural approach. Remember that the architectural approach, it's just a suggestion at this point. It's just a point of discussion. And when you start an ATAM, you actually have to leave your ego outside of the room and decide that now it's the time to really look at this architecture and understand critically what I'm missing and what is missing and what we can do differently. During the analysis, you have the quality attributes that get reviewed, clarified, prioritized, and the team identify the scenarios to satisfy the quality attributes. In the testing phase, you test the architecture and the quality attributes accordingly to, you test the architecture against specific scenarios that are nothing more than a specialization of the quality attributes that you define. Reporting, it's a set of decisions that you have made, a set of trade-off that you made, and usually a next step to modify and update the architecture to match the outcome of the discussion. When you present the business drivers, it's important that you find a way to have these business drivers staying with the team and staying with the architects also after the presentation. There are business owners that prefer to use slides. I really recommend using documents. Slides, as you see, there is some content and somebody that is talking about. Slides without somebody that is talking really lose effectiveness. So a document, it's usually a really good form to express the thought process and the business drivers. A simple technique that is used in many companies now, not only at Amazon, it's PRFAQ. PRFAQ documents are nothing more than frequently asked questions that you are assuming that your customers will ask once the service or the app is launched, and you answer to that. This is an interesting and fascinating way to describe your business drivers. When the architects presented the architecture, they have to show to the stakeholders at least the functional code development, concurrency, and physical views. The functional view is an abstraction of the system functions and their relationship. It's used to describe the domain, the component of the domain, and assess the functionalities and how data flows between any portion of your system. The code view contains components in smaller projects, maybe modules and classes, but most likely components, and their composition into subsystem or layers or modules. The development view is the structure of the source code. Usually it's nothing more than your repository and how you are structuring things, because you can assess the modifiability and maintainability of the system through that. Concurrency view describe the processes that will be created and how they communicate together. You can assess deployment if you're talking about a backend application, but you can also assess availability of a system when you're talking about an Android app. For instance, if you have a module that it's running for you some task and fails, you can understand how the rest of the app will behave. The physical views is nothing more than the physical computers, infrastructures on which your system will be deployed. The analysis phase, it's when the team altogether with the evaluation team as a main driver identify the architectural approach, maps architectural decisions with quality attributes, and generate an utility tree. The utility tree is a prioritized map of scenarios that make them concrete and actionable. For instance, stability. It's one of the quality attributes that a lot of time you will hear, right, around an app. App does not crash, force close, freeze, or otherwise function abnormally. That's a very common definition. In Android, how do you reduce the ANR rate, for instance? You can optimize thread usage. You can optimize networking by reducing network traffic with caching. You can optimize the time to respond to a broadcast message, many others. But at the end of the day, if you don't go deep and you don't start to prioritize and understand the weight of each of these sub items of equality attributes, you will not be able to achieve exactly what the stakeholder has in mind. For instance, let's look at this utility tree. Let's imagine that we have our ideal app where we have stability, modifiability, availability, and security. 4 quality attributes. In stability, you have 2 components, actually 2 sub-quality attributes, ANR, application not responding, and service failures. Forget about service failures. On ANR, you have 2 potential subset of these quality attributes that are minimize the I/O operations on the main thread and reduce the response time to broadcast message. The second one is still ambiguous, right? You don't have an ideal measurement of the reduction of the response time, but still give you an idea. The ML that you see between parentheses is nothing more than the effort versus the impact. If we minimize the I/O operation, the effort is minimum, right? We can use Kotlin coroutines, we can use workers, we can use many techniques, right? It's not that complicated. It may be complex, but not that complicated. The impact is very large. Same to reduce the response time to broadcast message. It's not something that now we are using. It's full of resources, full of materials. It's a medium complexity task, but it's a large impact. You usually prioritize these leaf of your utility tree, these leaf scenarios of the utility tree, having first what is complex to be implemented and what is a large impact. So an LL will be extremely important. ML will be a priority number 2. You leverage this technique to understand if your quality attributes, the one that you had at the beginning, are in a real priority order. You have to be open-minded. The outcome of the utility tree exercise can be surprising and bring to the prioritized quality attributes. Maybe you will discover that security is not that important. Maybe, right? There are edge cases where this can be true. What is important is that when you are assessing the architecture, you do this with questions. One important aspect of being a good citizen in the ATAM, it's being curious, open-minded, and keep your brain understanding what are the intentions of the architecture that is getting presented. You can ask performance-related questions like, what are the latency requirements associated with each message in the app? How critical is to meet the latency requirement? You can have availability questions like what mechanisms are used to detect and recover from failures. It can be simple as a client-side fallback mechanism. It can be an S3 bucket that when a service is down will leverage a cached version stored online of the data that you have for your app. You can have modifiability related questions, like what type of changes do you anticipate during the lifetime of the app, and how the system will be able to handle and accommodate these. Can be configuration files, can be anything. When you test the architecture, you run the architecture through the scenarios that you identified with the utility tree. So, of course, you will have surprises and you will have outcomes that are unexpected. Which scenario you test? Use cases scenarios that are how the users interact with the system. Growth scenarios in which you want to validate how the system react with more users, with reduced latency. You can ask and understand how the app system behaves with reduced connectivity speed, how the app system manage a change in the data structure, how the app can process a data set that double in size. And you can have explorative scenarios. These are scenarios that expose the limitation of the system. What is the impact if the system app part of the system go down? What is the impact if you have to port part of your services from one platform running on Linux to Mac, for instance? What is the impact of improving the availability of your app from 98% to 99.999%? These are all scenarios that come out from the utility tree and that you have to leverage to validate the architecture. The validation produces a list of risks and not risks. The non-risks are the strengths. In strict terminology from a software architecture perspective, you use the non-risk word, but imagine that as the strength of the system. The risks are the weakness. You know that your system will potentially fail for a specific risk and specific reason. And it's your opportunity during the ATAM to list them out. Additional outcomes that come out from the ATAM are prioritized scenarios, architectural decision changes, sensitivity point, and trade-off. Sensitivity points are architectural decisions that involve one or more components that are critical to achieving a quality attribute. Imagine level of confidentiality of the data that can change, latency when processing a message, effort to deploy a system. Trade-offs are architectural decisions that affect one or more quality attributes, changing the level of encryption because it impacts, for instance, security and processing time, that are performances. Changing from an observer patterns to data stream when supporting use case of synchronous collaboration. It happened to me. I was working in an app and they were doing everything with subscribers, but at some point they needed a tool to control the remote screen of a user and navigate the user through the step of the app. Of course, this was an architectural change and we had to make some trade-off. Instrumentation, it's a typical trade-off, right? The more code is instrumented, the more it's easy to understand the behavior and how the code get executed during runtime. But however, you are compromising and making a trade-off on performance because the more you instrument, the more you will be impacted on performance. The results of these are notes that are structured in a single-pager document, in a one-pager document, that usually summarize the clarification of the assumptions, the decision records that you made, and the prioritized use case. Through all this process, you can say that you made a deep assessment of your architecture. But as you can imagine, this is cost-effective, right? And there are it's not definitely possible to do it every time or doing it very often. Arthur, any question from you or from the attendees before we move to how to work on intermediate architectural reviews?
Sure. Yeah, there is a question from Ruslan, and he asks, basically, his question is something in between of modifiability and security quality attributes. And the question is, okay, from one point of view, we want to make everything modifiable so we can easily change it and so on. But at the same time, we may have some parts in the code that we would like to have untouched due to some like security reasons, due to the fact that, okay, maybe we have already fixed this thing because we understood that there is security, so don't touch this. And how do you think, what is the best way to make sure that the future decisions, both like architectural and like low-level code, satisfy both modifiability and this like non-modifiability kind of intended
Yeah.
non-modifiability in some cases?
Absolutely. Great question. Well, this is the answer, obviously, it depends, right? It depends on the context of the app. But overall, this is this is really specific to ATAM. This is a trade-off. At some point, you have two quality attributes that are competing with each other, modifiability and security. You need to understand where you have to stop to modify, to make your system and your app modifiable without exposing any critical data. So you need to run an analysis on the criticality of the data, confidentiality of the data, leverage a security expert, or at least applying some security constraints, and understand where you have to stop and identifying boundaries. There might be red zones in your app of code that you don't want to touch or you don't want to make modifiable for this security reason. For instance, I remember that once I was working on a system that had a concept very similar, where the processes in charge of manipulating um, confidential data were stored in servers that were in somewhere, nobody knew where, and only executives and VP had the keys to access that server. So you create your boundaries. Can be on the back end, on the front end, doesn't matter. You can achieve that, for instance, instead of deploying source code, building libraries for specific part of for security, or building an SDK and obfuscating the code. Then you can keep still your system very modifiable, but at the same time you create the boundaries of security that you need.
Yeah, that sounds interesting. And I have a couple of items about the different views on architecture. First of all is physical view. For Android apps, it's probably very simple. Like, okay, Android phone.
Yes, that's very true.
Cool.
That's
And the
very
second
true.
one is.
But sorry, but to the point that you made before, for an Android app, should be just a phone, right? But if it's an app that is tailored for multiple devices, right, that can run on multiple devices, then you might have, yes, you might have some discussion over there. But good point, thanks.
Sure. And another one is about this code level of architecture when we're talking about modules and stuff like that. And this question is actually bubbles up a little bit higher even at like, what are the types of decisions, what are the types and level of features that we should conduct ATM at all? Because if you're talking about, oh, okay, there is already, I mean, there is nothing and we need to create an app, of course, like there are lots of decisions that we need to make basically. But if the app does already have like 100 of features and we need to add the 101st, 101st, probably we shouldn't spend so much time of thinking. Or basically, what's your opinion on this?
Well, my opinion is that of course you have to invest time of thinking. You have to be able to assess with your stakeholders, architects, and external reviewers if it's worth to go deep. Maybe the 101st feature is not changing too much. But if you're working on an app that is in continuous development, there might be 20 different ATAM that are going simultaneously, and there are 20 features that get deployed this year. So it's important to make a reflection and understand if there is an opportunity to maybe run a parallel discussion and discuss how new features will be implemented, actually where it will be integrated. So it's always a question to have. It's important that the external team and the facilitator of the ATAM is able to park-lot these items for further discussion. But it's a question that you should always ask yourself. I have seen too many apps starting simple and became monolith to postpone, to don't ask this question.
Great. And yeah, I'd like to remind you that we have about 15 minutes left. And
Yes.
if we will have any like longer discussions, maybe for MV stuff, we can move them to the discussion zone after the talk. And now let's proceed.
Absolutely. Thanks for the reminder. So we were saying that ATAM is fantastic, looks like a great tool. There is a lot of work to do, a lot of outcome expected, but it's time consuming for sure, right? And there is also another big problem. ATAM happens when people think that the architecture is ready. But when an architecture is ready, it's hard to determine it, right? For me, it's a portion of an architecture is ready when all the discussion that must be done should be done by engineers at coding level. So when all the high level discussions are covered. But this is very hard to reach. So what I usually suggest is to leverage the good part of ATAM and split them in intermediate architectural reviews. Architectural reviews should be iterative and only stop when you decommission your system. Remember that every single line of code introduces a design change. Most of the time can be captured by a test update, but sometimes can create side effect. Architects must leverage stakeholders and intermediate reviewers to determine if they are going in the right track. So don't be shy, don't wait till the end. Expose yourself to criticism, because the criticism is not against you, it's against an architecture that may not be considered some part of the picture. To evaluate partial architectures, you have to identify the stakeholders and the reviewers, clarify assumptions, and verify use case. Embrace imperfection. It's important that you accept that misconceptions in your thought process can be everywhere, and that can be generated by lack of requirements, but also from unconscious bias on how a system should behave rather than how the system will really be. Keep challenging yourself and others with questions. Questions are the most important thing to any review, any formal review. And leverage external reviewers also in the partial architecture review, because an external reviewer can bring a viewpoint that you misconsidered. Of course, having this pre-release review generate a lot of value, because you can catch errors, you can catch misbelief, you can catch any misconception and misunderstanding very early, when it's way easier and more cost effective to support them. Let's talk a little bit more in depth about Android. So in Android, we have a plethora of model view whatever, right? We have model view controller, model view presenter, model view model view intent, model view update, and next year we'll have another letter coming here, and this talk can be done again with another layer. But they are trying to solve the same problems, right? The historical challenges that we have, it's separation of concern, having a code that is leveraging a single responsibility principle. You want to have reusable logic. The UI should be independent, easy modifiable. The app must be easy to test, easy to maintain, and you should have constrained as much as possible and isolate as much as possible your dependency on framework and other libraries. MVC is the more classic, right? It's when you have the controller that establish a relationship between view and model. I think it's more than 40 years old, if I remember correctly, and brought to the evolution of model view presenter that is similar to model view controller, but with a more decoupled view that is exposed through interfaces. You leverage interfaces to decouple your implementation. You want to keep the view as much as possible dumb and without any logic inside it. But the challenge that you have here is that the presenter tend to expand and becoming a huge I know everything class that can be your activity, that became way full of logic and hard to maintain. Again, the diagram is pretty similar to model view controller. It's the abstraction that here it's really making an interesting point. Also, if it introduces a learning curve. Model view model is now pretty well known, and The view model replaces the presenter in the middle layer, and while the presenter holds the reference to the view model doesn't. The view model also sends data streams, and you create a relationship between a view and view model that are one-to-many. It's still an interactive pattern, help you to navigate the complexity of building applications that respond to user interaction. We have then a model view intent that it's like MVP. We have interfaces that represent the view, but the intent represents an intention or desire to perform an action from a user. Can be from the user and can be by the app itself. For every action, a view receives an intent, and the presenter observes the intent, and the models translate into new state. The benefits are that you are introducing a state management that you can leverage immutability, and that can become your single source of truth. You have an unidirectional data flow, and you have a better separation of concern that bring you to maintainability. But how do you pick a pattern? It's only through questioning. It's only through observing your UI and understand how each part of the app interact with each other. You have a 50,000 feet where you look at your domain, constraint and quality attributes, and you identify the strength and risk area of your system. You, from this 50,000 view, come out with a clear understanding of what your system is and the problem that it's trying to solve. Then you go down and you go at 40,000 feet. You discuss the data layer and you want to understand what are the bottlenecks and are the dependencies that you have. You design your offline strategy, and you then start to think about the abstractions that you need to maintain the offline status. You go down even more, and you are at 30,000 feet, and you explore your screens, and you identify the modules of your app, and you start to organize your code in modules and break dependencies between each modules to make them deployable independently, testable independently, and you want to enable your developers to work on them independently. Then you go even another level down, and you design how to update the state of your app. You identify how to play with legacy that it's in your apps, and you establish your data flow patterns. And finally, when you fall down at 10,000 feet, you look at what I usually call as the leaf component and discuss the opportunity and challenges of the patterns above. You decide if you want to use MVC, MVP, MVVM, MVI. But one thing that is important to understand, and there is not a perfect choice. There is never a perfect choice. Okay, yeah, absolutely. And sorry, can you repeat the question? Because I was taking care, understanding why it was not working. So I was really not listening too much to you. Sorry, can you?
Yeah, sure. I mean, yeah, the question wasn't addressed to you, and I just this question was addressed to the audience, and basically the question was, okay, how do you select what to use, MVP, MVVM, and stuff like that? And I've asked them to share it in chat, or that we can discuss it in Zoom after this lecture, and you can continue with your slides.
Yeah, absolutely. I will take care of this, because the next section is exactly what we are talking about. It depends, right? We have so many opportunities to interesting now. Okay, so many opportunities to determine how which is the best architecture. Again, I usually look at the use cases. I usually look at what is the legacy, what are the decisions. And one thing that I try to understand, it's how I can make an architectural change without forcing the entire app to be re-architectured. That's the first driver that I look at. Another thing that I look, it's the team structure and the organization structure in which I'm working. We can have centralized teams and federated teams. Centralized teams can own an entire app and its architecture. That's one of the easiest case. It's when you can have discussions with other leaders, with other contributors, and understand what are their constraints, what are the concerns, what was working well, what was not working well. You usually pick up on test, because if you have problems in writing test, unit test, and test automation, there is usually some dependency concern in your application that can make this difficult. Then you start to explore federated teams. You check if you have in a federated environment. You look at federated teams and you understand if they work with a single architecture or with multiple architectures. With a single architectures, it's very hard to make a change, at least from a centralized point of view. But you can still discuss. But at the same time, you have the benefit of having basically the same architecture in every single screen. These bring you to unexpected surprises. Sounds fantastic on paper, but is one of the most dangerous things. As soon as your architecture doesn't embrace the fact that there might be specific needs for specific components in your app to use MVVM rather than MVI, then you're failing, because it's impossible to predict when you design the architecture all the use cases that all the way that the customers, users want to interact with your app in time. So you will constrain yourself. When you have a federated team, that means that every single team owns a specific part of the application, and you have multiple architectures, you can embrace the freedom of having a team owning their own decisions. This sounds, again, great, but can create some challenges. One, for instance, is how do you propagate the status changes into the system, how you share information, how you communicate with each other module. So it's always hard, and it's always a balance. For me, the perfect combination is having a single architecture for data flow, and then let the owners of the leaf of the system deciding if they want to use model view model, model view intent, or model view update, or whatever that it's more suitable for their system. Conclusions. So we look at techniques to dissect your architecture, your requirements, to understand what are the quality attributes that you have to fit. We discuss what are the common patterns that you see in Android. And we understood and learned that there is not a perfect secret sauce. There is not the best architecture to use. There are architectures that better fit the quality attributes of your system, and that better fits the use cases of your application. It's your job and your responsibility to stay open-minded and don't do any dogmatic battle about which paradigm to use. Prioritize your customers. Keep in mind that at the end of the day, what is important, it's what you are delivering to your customers. Leverage ATAM, leverage intermediate reviews, and embrace the imperfection, because our life as software engineers, it's made up by trade-off and compromises that we do on an everyday basis. That's it. Please feel free to reach out on Twitter or on any other tool or LinkedIn if you need or you want to discuss deeply.
Great. Giorgio, thank you a lot. That was an interesting, that were the interesting thoughts about how to decide what to basically need and how to decide what is your architecture should be. And I think that the conclusion that there is no silver bullet is maybe sad, maybe, I don't know, good news for us, but this is definitely something to be aware of. And for any questions that you might have, our audience, now we'll switch to Zoom chat, when you can ask these questions directly to Giorgio. I will probably chime in if I will have any position on that. But I think that we have finished. So thank you, Giorgio.
Thank you so much.